Welcome back. In this video we continue our review of the common annotation tools of text, dimensions, and leaders in AutoCAD. Tools that are found in the Annotation panel on the Home tab and in the Annotation tab of the ribbon. These annotations of text, dimensions, and leaders are the parts of our drawing presentations that clearly describe and define our designs and models. Without these descriptive elements applied to the drawings we produce, our drawings lack meaning and context. As reviewed in our previous video, annotative scaling is the mechanism that controls or manages the visual sizing or resizing of annotative objects as displayed in the viewport windows of our page layouts. Open your previously saved My Drawing file so we may continue developing our personal drawing template. Once the drawing file is open, be sure to switch to Model Space from any page layout tab the file may be currently opened to. To simplify our drawing environment, delete or erase all existing geometric objects that may have been created, keeping the text object we placed at the 0, 0 coordinate point, and save your drawing. As mentioned in our last video, the importance of only assigning annotative scales to objects actually in use. Let's remove the overassigned annotative scales applied to our existing object. Select our text object. In the right-click contextual menu, left-click on Annotative Object Scale, and then left-click on Add Delete Scales. In the Annotation Object Scale dialog box, hold down the Control key and select all of the scales with the exception of 1/4 inch equals 1 foot, 1 inch equals 1 foot, 3 inches equals 1 foot, and 6 inches equals 1 foot. The scales assigned to the viewport windows in our Layout tab. Left-click on the Delete icon at the right-hand side of the dialog box. Recheck and affirm that only the 1/4, 1 inch, 3 inch, and 6 inch scales remain in the list, and then left-click on the OK button to exit the dialog box. Let's quickly review a few of our Draw Tool commands and create some new geometry. Enter the Circle command, and at the command line prompt to specify the center of the circle, type the coordinate point 0, 0 and hit the Enter key. At the next command line prompt to specify the radius of the circle, type 2 and enter. Enter the Rectangle command, and at the command line prompt to specify the first corner, again type the coordinate 0, 0 and hit the Enter key. At the next command line prompt to specify the opposite corner, type the @ symbol and the relative unit distance 6, 4 and press the Enter key. Re-enter the Rectangle command, and at the command line prompt to specify the first corner, choose the bottom or 6 o'clock position of the circle as the first corner point. At the next command line prompt to specify the opposite corner, type the @ symbol and the relative unit distance 48, -15 and press the Enter key. Let's revisit one of our modify commands. Enter the offset command by selecting the offset icon in the modify panel of the Home tab or by typing O and enter in the command line. At the next command line prompt, type 10 and enter to specify the offset distance. At the next command line prompt to specify the object to offset, select the circle, and at the prompt to specify the point on the side to offset, move your cursor away from the circle and left-click to place the new circle. Press the Escape key or the Enter key to exit the command. Enter the polyline command, and at the command line prompt to specify the start point, choose the upper right corner of the large rectangle. At the next command line prompt to specify the next point, in the command line, type TAN for tangent and hit enter. Place your cursor near the 1 o'clock position on the large circle. When you see the green snap point icon, left-click to complete the polyline. Press the Enter key or the Escape key to exit the command and save your drawing. We now have in place geometries we can use to explore the dimensioning and multi-leader tools. Before we begin exploring the various dimensioning tools, let's take a moment to refine and define the standards we wish to apply so that the varied components display legibly for us in both model space and in our paper layouts. In our last video, we created new text styles using the Text Styles Manager. In this instance, we will use the Dimension Styles Manager to make our desired changes. In the Annotation panel, on the Home tab, to the right of the word Annotation at the bottom of the panel, select on the pull-down arrow. In the second row of this flyout tab, we see that the AutoCAD standard dimension style is the current dimension style set to be used, and that this dimension style is not annotative, as evidenced by the missing blue annotative icon. By left-clicking one time on the dimension style pull-down arrow, we see that there is a second dimension style available to us. This dimension style is titled Annotative and has the blue annotation icon to the left of this title. Left-clicking one time on this icon toggles or switches it to be the current text style that will be used moving forward. At the left, we see the icon for the Dimension Styles Manager. Left-click one time on the Dimension Styles Manager icon to access the Dimension Styles Manager dialog box. Note that the annotative dimension style is highlighted in blue, indicating it is the current style. Left-click one time on the Modify icon at the right side of the dialog box. Across the top of this dialog box are 7 tabs labeled Lines, Symbols and Arrows, Text, Fit, Primary Units, Alternate Units, and Tolerances. The alternate units and tolerances settings are generally used for mechanical drawing purposes, and we will not be making any adjustments to the settings in those tabs at this time. In the upper right corner of this dialog box is a graphical preview of the current settings for this dimension style. Select the Lines tab to modify the dimension line portion of the dimension string. A dimension line is a thin, solid line that shows the extent and direction of the object being dimensioned. Note the setting for color, line type, and line weight are currently set to by block. This by block term means that no property is assigned to the object other than the native properties of the object when the block is created. A block is a collection of objects that are combined into a single named object, in this instance, a dimension string. We will leave these settings in place. Extend beyond ticks gives the user the ability to allow the dimension string to extend beyond the point where the dimension line meets the extension lines. It is this intersection point where some type of mark or tick is placed to define the point where the measured dimension value stops. The current tick marks, as displayed in our preview, are currently closed arrowheads. We will address ticks further when we visit the Symbols and Arrows tab. We will leave this current Extend Beyond Ticks setting at 0. Baseline spacing is the distance the dimension string text is offset from the dimension line. We will change the current value to 3/32 of an inch. Keeping in mind that this is the value and distance the user wishes to graphically see in a scaled viewport window on a layout page. Checking the option to suppress the dimension line simply means the dimension line will not be displayed. We will leave these boxes unchecked. In the next section below is the area to modify the extension lines portion of the dimension string. Extension lines are dark, fine solid lines that extend outward from a point on a drawing to which the dimension refers. Usually the dimension line meets the extension line at right angles. Extension lines also never touch or are offset from the object being dimensioned. Note the settings here for color, line type extension line 1 and 2, and line weight are all set to by block. Similar to the section above, we will leave these settings in place, as well as leaving the suppress extension lines 1 and 2 unchecked. We will change the value for extend beyond dimension lines and offset from origin to 3/32 of an inch. Checking the fixed length extension lines box allows the user to limit the length of extension lines. This can be a useful setting for certain detail type drawings, but we will leave this box unchecked. Left-click once on the Symbols and Arrows tab. In the Arrowheads section, left-click one time on the pull-down arrow for the first arrowhead. Scroll down and select Architectural Tick. Note that the second arrowhead setting has been automatically changed. Also note the changes in the preview pane. For the leader arrowhead, since leaders are used to point at objects, we will leave this setting as a closed filled arrow. Again, we will change the arrow size to the familiar 3/32 of an inch. In the center marks section, we will change this setting to none. Center marks are used typically in mechanical drawings to identify the center point of circles, arcs, or other station points as references critical in the machining and fabrication processes. The arc length symbol is to be set to preceding dimension text. This is to keep the full arc dimension text in a linear form. The radius jog dimension is a graphical cue that the dimension line doesn't point to the center of a circle or arc being measured. The angle value determines the cant angle applied to the dimension line. Linear jog dimension employs jog lines like a break line symbol and are used to represent a dimension value that does not display the actual measurement in a linear dimension. The jog height factor is simply a multiplier applied to the text font height value that determines the height of the jog lines. We will leave these current settings as is. Navigate to the Text tab. Note the current text style is set to the AutoCAD standard style. In our last video, we created additional text styles. Left-click on the text style pull-down arrow and choose Roman S as the new text style. Note that left-clicking on the small square with the 3 dots will open the Text Styles Manager dialog where the user has the option to make changes to existing text styles or create additional new styles. We will leave the text color set to by block and the fill color set to none. But we will change our text height to our 3/32 of an inch height. We will leave the draw frame around text unchecked, as this additional geometry of a text frame often tends to clutter the drawing area. In the text placement section, change the vertical placement to above, as we want our text to live above our dimension line, and change the offset from the dimension line to 3/32 of an inch. In the text alignment section, change this setting to aligned with dimension line, and note the changes in the preview pane. Navigate to the Fit tab. We will not make any changes on this tab, but do review and make note of the current settings, and that the checkbox for annotative in the Scale for Dimensions Features section is checked. Navigate to the Primary Units tab. In the Linear Dimensions section, left-click on the Unit Format pull-down arrow and change the unit format from decimal to architectural. Recall in our previous video our discussion regarding precision and the philosophy for setting the precision value to the lowest value the software provides. We will employ that same philosophy of allowing the software to show the user minute drawing errors and the opportunity to make appropriate corrections here. Left-click on the precision pull-down and scroll down and choose the 1/256 of an inch precision. Left-click on the fractional format pull-down and change this setting to not stacked. This not stacked format keeps the text object linear in form. Leaving the fractional values in a stacked or horizontal format or a diagonal format impacts the offset spacing of the text from the dimension line. This text offset condition can impact the legibility and spacing of stacked dimension strings. Selecting any positive value for rounding off dimensional values runs counter to our reasoning for choosing our precision setting. This round-off value shall remain as 0. Our measurement scale is to remain as a value of 1, since we are using annotative scaling to manage our annotative dimension style. In the zero suppression section, we want the 0 feet box to remain checked, but to uncheck the 0 inches box. The reasoning here is that we would never want to see a dimension of 0 feet 8 inches, but we do wish to see dimensions of 8 feet 0 inches. In the angular dimensions section, unless the user is performing civil or other engineering work, decimal degrees is the proper setting. Likewise, unless the user anticipates working often with geometries that have measured angular values less than a whole degree value, applying any decimal precision here is unnecessary. An alternative option to this strategy is to add a decimal precision value, but to also check the trailing checkbox in the zero suppression section. As noted earlier, we will not be addressing the alternate units or tolerances tabs at this time, so click OK. Close the Dimension Styles Manager dialog box and save your drawing. Before we create our first dimension, let's take the opportunity to explore how layers are used to organize our various drawing elements. In the Home tab of the ribbon and to the right of the Annotation panel is the Layers panel. A comfortable way to think of layers is to think of each individual layer as an individual sheet of trace paper or vellum, where each individual sheet contains drawing-specific types of items. For instance, we may draw all our geometry on one layer or individual sheet, place all our text on a second layer or sheet, and our dimensions on a third layer or sheet. When all three sheets are stacked on top of each other, we see a complete drawing composition. If for some reason we do not want to see our text, we would simply remove the sheet containing our text from the stack. When we again wish to see our text, we would add this sheet back into the stack. In this way, layers serve two main purposes: to separate different drawing elements and to control where and when we wish to see these different elements, both in model space and within our drawing layout viewport windows. At the top right of the Layers panel, we see a bar that has a series of icons, and at the right end of this bar, a pull-down arrow. Left-click one time on this pull-down arrow, and we see a contextual list expand. Yet at this time, we only have the one native AutoCAD 0 layer in our drawing file. Hit the Escape key one time to release this flyout menu. At the left-hand side of the Layers panel is a large icon labeled Layer Properties. Note the symbolism on this icon reflects a layered stack of papers along with a small dialog box icon. Let's left-click one time on this Layer Properties icon, and the Layer Properties palette should open at the left-hand side of your display. If this palette has not been accessed previously, you will wish to right-click one time on the dark gray control bar where the words Layer Properties Manager are printed to uncheck Allow Docking and to check Auto Hide. These are the same options we applied earlier to our Properties palette. Left-click and hold on the dark gray bar and drag the Layer Properties Manager to a convenient out-of-the-way location on your display. Hover your cursor over the Layer Properties Manager and allow the palette to expand. Stretching across this palette are a series of columns, and you may wish to expand the width of these columns as necessary to fully read the names on each column for clarity. At the far left, the first column is labeled Filters, and as the name implies, creating various filters to separate or group certain layers can be created to show and hide and organize content. We will explore this area in future videos. Moving to the right, the first column is labeled Status. In this column, we see a green check mark applied to the only layer in our drawing file, the 0 layer. This green check mark signifies in this palette which drawing layer is the current drawing layer. The next column to the right is the column where layer names are defined. We will explore layer naming in a moment. Moving to the right is a series of columns where the user controls the properties of the individual layers. The first column in this section is titled On. In this column, we see an icon that looks like a light bulb. Intuition tells us that if the layer is set to be on, this icon will appear to be lit, and if the layer is set off, the icon will appear to be unlit, and the objects on this layer will not be visible in the display. The next column to the right is labeled Freeze. A convenient way to interpret this is to think of an ice cube. The icon in this column currently appears as an illuminated sun under which ice cubes melt. Therefore, when the sun is shining, the layer is thawed and the objects on this layer are visible. And if the icon appears as a snowflake, the layer is deemed frozen, and in the display, the objects on this layer will not be visible. The next icon to the right is titled Lock, and the icon is that of a padlock. When the icon appears as an unlocked padlock, the objects that live on this layer are accessible to be selected and manipulated. When the padlock is closed and blue, the objects on this layer cannot be modified and are inaccessible. A visual cue in the display for the user is that objects on the locked layers appear dim, and even though the user can select on these objects, any object snap grips do not appear. The next column to the right, the icon is that of a printer. This is the Plot column. When the printer is white, it tells the user that all objects on this layer will print. By left-clicking one time on this icon, a small red circle appears with a small minus sign over the printer icon. This tells the user that objects that live on this layer will not print. The next column to the right is titled Color. We assign specific colors to layers to provide visual separation of our drawing objects. Left-clicking one time opens the Select Color dialog palette. Note that there are 3 tabs at the top of this palette: Index Color, True Color, and Color Book. The Index Color tab contains the 255 native colors in AutoCAD. Each color has an index color number. We see that the current color is called white and is index color number 7. Color number 7 appears as white on dark backgrounds, such as in our model space display, but will appear as black on bright colored backgrounds as we have seen previously in our paper layout. This bar of colors, numbered 1 through 9, relates directly back to when color plotters actually used physical pens mounted in a carousel. The industry standard for these pens were red pen number 1, yellow number 2, green number 3, cyan 4, blue 5, magenta pen number 6, and black pen in number 7 to print on white paper. To select or change a layer's color, the user can either type the color number down in the text box at the lower left, or click on any of the colored squares in the palette above. Note the color palette is divided into 2 sections. The upper palette, the colors are bold and even numbered, and the colors in the lower palette are pastel and odd numbered, and the color numbers increase in index value from left to right. An important note: at the midpoint on the right-hand side of the palette, the true color red, green, blue values are displayed for each index color. Let's quickly select on the True Color tab, where we are presented with the ability to define any of the 16 million available True Color options. As a word of caution, though, if the user is not intending to print a color document, the use of true colors should be avoided, as true colors in the drawing document cannot be made to print as black. Yes, the user can override the printer settings to print grayscale, but this can lead to much trial and error to obtain acceptable grayscale output. The use of true colors is best restricted to the production of graphically colored presentation documents or the occasional need and purpose for specific objects to print in color. Let's navigate back to the Index Color tab and then exit the dialog by selecting OK or the X in the top right corner. The next column to the right is titled Line Type and is where specific line types such as center lines, dash lines, phantom lines, etc. are assigned to the layer. The next column to the right is titled Line Weight. Line weight is critical to creating meaningful drawings. Depending on the plot style configuration being used to send the drawing data to the output printer, a subject we will get to in our next video, defining line weights to layers here can be very important or irrelevant. The next column to the right is titled Transparency. In this column, the user may apply a global transparency value to all objects created on this layer. Think of the use of transparency as telling the output printer to use less than 100% ink for these objects, resulting in some level of grayscale output. Use of the New Viewport Freeze option in the next column to the right can be very helpful. Each time a new viewport is created, all layers by default are shown, as drawing files can become rather complex, containing tens if not hundreds of layers. Having this new viewport freeze option active can keep the user from needing to spend excessive amounts of time managing the individual layers within newly created viewports. While we are here in this Layer Properties Manager, let's create 3 new layers. Above the word Status appears 4 icons. Each shows a stack of layers. The left icon has a sun image and is the Create New Layer icon. The next icon to the right is the Create New Layer with Viewport Frozen icon. Using this new layer creation tool automatically toggles on the New Viewport Freeze option previously discussed. The next icon to the right has a red X, and this icon, when selected, activates the ability to delete existing layers. A word of note, existing layers cannot be deleted if there is any object remaining within the drawing file on that layer. The last icon has a green check mark and activates the tool to select an alternative layer to now become the current layer. Left-click one time on the Create New Layer icon. We now see in our layers list a new layer has been created, duplicating all of the settings of the current layer, and is assigned a default name, Layer 1. Left-click on the Layer 1 name and rename this layer Geometry, and press the Enter key. Left-click on the color icon, and in the Select Color palette, change the color for this layer to Color 4, Cyan, and click OK. Select again the Create New Layer icon. Rename this layer Dimension. Press the Enter key. Left-click on the color icon and change the color for this layer to Color 3, Green, and click OK. Select one last time on the Create New Layer icon. Rename this layer Text and change the color of this layer to Color 2, Yellow, and click OK, and save your drawing. In the Status column, double left-click on the blue diamond-shaped layer symbol next to the word Geometry to set the geometry layer as the current layer. Move your cursor off the Layers Manager, and assuming Auto Hide has been assigned to this palette, allow the palette to collapse. We now see in the top bar of the Layers panel that the geometry layer is the current layer, and the color is cyan. Allowing our cursor to hover over the Properties palette next to the word Layer, we see that the layer Geometry is the current layer. The color is cyan with the words By Layer next to it. By layer meaning the color natively assigned to this layer. Switching to or changing layers can also be accomplished here in the Properties palette by pulling down this list, as well as in the Layers panel in the Layers list pull down. All of the geometry we have previously created still resides on the 0 layer. Select all of the geometry without selecting our original text object. Move your cursor up to the Layers list pull down in the Layers panel and select on the word Geometry. Hit the Escape key a few times to let go of the geometry, and note that all of our geometry now is cyan in color and resides on the geometry layer. In the status column of the layer, let's now add some dimensions to our geometry. Our first step, though, is to ensure that we are on the correct drawing layer, in this instance our recently created dimensions layer. In the Layers list pull-down of the Layers panel at the top center of your display, left-click one time on the word Dimensions in the list to make this the current layer. On the Home tab of the ribbon and in the Annotation panel, in the upper right corner of this panel is an icon labeled Linear. To the left of the linear label is an icon image of a dimension string, and to the right of the linear label is a pull-down arrow. By selecting on this pull-down arrow, we see a series of commonly used dimension types. The topmost icon is the linear dimension command. Hovering your cursor over this icon and allowing the mini tutorial fly out, note that the command name for this command in the command line is dim linear. The linear dimension tool is used to articulate the distance or length of objects oriented to the X and Y coordinate planes. There are 3 steps to placing a linear dimension. Left-click one time on the linear dimension icon in the upper right corner of the Annotation panel. The command line prompt asks the user to specify the extension line origin. Select the bottom left corner of the large rectangle. The next command prompt asks the user to specify the location of the second extension line origin. Select the bottom right corner of the large rectangle. And the third command line prompt asks the user to specify the dimension line location. Pull your cursor down a short distance and left-click to place the dimension line and exit the command. Re-enter the command by pressing the Enter key. Select the lower right corner of the large rectangle as the location of the first extension line origin, and the upper right corner for the second extension line origin. Pull your cursor off a short distance and left-click to exit the command. Recall that the linear dimension tool only provides dimensional distances along the X and Y axes. As this relates to our angled line that stretches from the top right corner of the large rectangle and runs tangent to our large circle, the only values the linear dimension will provide are the relative changes of this angled line in the X and Y directions. To accurately measure the length of this line in the Annotation panel, pull down the Dimension flyout menu and left-click one time on the Aligned Dimension tool. And we will follow the same steps as we did for the linear dimension command. Select the upper end of the angled line where it connects tangent to the large circle. Then left-click one time on the bottom end of the angled line where it connects with the top right corner of the large rectangle. Pull your cursor away a short distance and left-click to exit the command. Note how the fraction portion of the dimension reads in a linear form and the displayed precision value of the fraction in this dimension. In order to use the arc length dimension command, we need to first trim a portion of our large circle away so that we are left with an arc segment. Enter the trim command by either selecting the icon in the Modify panel or typing TR and Enter in the command line. Select on the segment of the large circle that lies inside the large rectangle and press the Enter or Escape keys to exit the command. In the Dimensions pull-down, in the Annotation panel, left-click one time on the Arc Length tool icon, and following the command line prompt, select the arc we just created. Similar to the other dimension commands, pull your cursor away a short distance and left-click to place the arc dimension and exit the command. In the Dimension pull-down menu, left-click one time on the Radius Dimension tool. Left-click one time on the small inner circle. Move your cursor to approximately the 8 o'clock position and left-click to place the radius dimension. In the Dimensions pull-down menu, left-click one time on the Diameter Dimension tool. Again, left-click one time on the small inner circle and move your cursor to approximately the 10 o'clock position and left-click to place the diameter dimension. Re-enter the Radius Dimension tool. Left-click one time on the arc segment. At the command line prompt to place the radius dimension, use the 9 o'clock quadrant position to place the dimension and left-click. Save your drawing. Let's explore inserting a multi-leader. But first we want to verify or modify the properties of our leader style. Left-click on the pull-down arrow next to the word Annotation in the Annotation panel. And left-click one time on the Multi-Leader Style Manager icon. This opens the Multi-Leader Style Manager dialog box. Note that the AutoCAD standard leader style is currently highlighted as being the current leader style. Left-click one time on the Annotative Leader Style, and then left-click one time on the Modify tab at the right side of the dialog box. Our process here is similar to the process we followed in modifying our annotative dimension style. We have a preview pane in the upper right hand corner showing us a preview of the current leader style settings. Note that there are 3 tabs in this dialog box. They are labeled Leader Format, Leader Structure, and Content. Navigate to the Leader Format tab if it is not currently selected. In the General tab area, we will not make any changes. In the Arrowhead section, as mentioned previously, a leader points to an object, so we will leave the arrowhead symbol as a closed-filled arrow. Change the arrowhead size to 3/32 of an inch. Navigate to the Leader Structure tab. In the Constraints section, ensure that the maximum leader points is set to 2 and that the checkbox is checked. In the Landing Settings section, ensure that both checkboxes for Automatically Include Landing and Set Landing Distance are checked, and change the landing dimension to 3/32 of an inch. In the Scale section, note that the annotative checkbox is checked. Navigate to the Content tab. In the multi-leader type pull down, ensure that the type is set to mText, meaning that paragraphical text is applied to this multi-leader style. In the Text Options section, change the text style to Roman S and change the text height to 3/32 of an inch. In the Leader Connection section, ensure that both the left attachment and right attachments are set to middle of top line and change the landing gap to 3/32 of an inch. Click the OK button to exit the dialog box and ensure that Annotative is highlighted to be the current leader style. If it is not, left click on it one time and choose Set Current to ensure that this is the current leader style, and then click Close to close the dialog and save your drawing. Before we place our first leader, our first step is to ensure that we are on the correct drawing layer. In this instance, our recently created text layer. In the Layers list pull down, left click one time on the word text to change the text layer to be our current layer. In the Annotation panel on the Home tab of the ribbon, left click one time on the Leader icon tool. Following the command line prompt asking the user to specify the leader arrowhead location, the object you are pointing at and wishing to describe, left click on the midpoint of the small rectangle. At the next command line prompt asking the user to specify the leader landing location, move your cursor up to the right and left click to place the landing point. Once the landing point has been selected, the multi-line text formatting toolbar pops up along with a multi-line text box with a flashing cursor attached to the leader landing position. In capital letters, type the word rectangle and either press the OK button or double-click outside the text box to exit the command. Our leader and text object reside on the text layer, and our leader is yellow, the color assigned to the text layer. Let's explore one more leader tool. In the Leader pull-down menu, left-click one time on the Add Leader icon. At the command prompt to select a multi-leader, left-click one time on our leader. At the next command line prompt, to select the arrowhead location, select the midpoint of the top line of the large rectangle. Press the Enter key or hit the Escape key to exit the command and save your drawing. Navigate to your Layout 1 page Layout tab. What we see here is really light colors such as yellow and cyan are extremely difficult to view on a white background. Let's make one change to our display in both Model Space and our Layout tab. Let's navigate back to Model Space, and in the big red A menu in the upper left-hand corner, at the bottom center of this menu, left-click one time on the Options tab. Left-click one time on the second tab from the left labeled Display. And 2/3 of the way down, left-click one time on the tab labeled Colors. In this dialog box here, we are able to modify the colors associated and seen in our model space, our sheet layout tabs, as well as other viewing options. Notice in the background, our 2D model space is currently a grayscale and not a true black color. Under the Color Pullout tab in the upper right-hand corner, left-click one time on the menu, scroll down, and change the color to black. Navigate in the left-hand context panel to the Sheet Layout tab, and again over in the right-hand color pull-down, scroll down and choose the color black. At the bottom of this dialog box, select Apply and Close, and at the bottom of the Options dialog box, select the word OK. Note how your model space colors show much more vibrantly with a true black background. Navigate again to your Layout 1 Page Layout tab. And here now, with a black background, we are able to clearly see all of our layer colors, similar to the same way we see them in model space. Note that we can see bits, parts, and pieces of our geometry in each of the 4 previously created viewport windows, yet we only see our newly created dimensions and leader in the top right viewport window. The viewport window scaled to 1 inch equals 1 foot annotation scale. The annotation scale set in model space that was current when these annotative objects were created. Double left click inside the upper right viewport window to open it. At the bottom right corner of the display, unlock this viewport by left clicking on the padlock icon. Pan the view so that the dimension string at the right end of the large rectangle is within the viewport frame. The arc and arc dimension are currently partially outside the view on the left-hand side. We will make an adjustment to the size of the viewport window next so that the arc and arc dimension are visible. Double left click outside the viewport to close the viewport window. Verify in the Drawing Aids toolbar that the 1 inch equals 1 foot scale is still current. If it is not, reset the scale, verify that the dimension string at the right end of the large rectangle is still visible within the viewport window, and then lock the viewport by left-clicking on the padlock in the Drawing Aids toolbar. Select both of the top viewport frames. Double-check and make sure that you are in orthographic mode by glancing down at the orthographic mode icon down in the Drawing Aids toolbar. If orthographic mode is not currently active, the icon is not blue, either left-click on the orthographic icon in the Drawing Aids toolbar or press the F8 key to make orthographic mode active. Hover your cursor over the shared top corner of the 2 viewport frames. The icon turns red. Left-click one time on the shared top corner grip of the viewports, stretch this grip point to the left just far enough to reveal the arc length dimension string. Left click to place the corner grip and hit the escape key a couple times to let go of the viewport frames and save your drawing. Looking at the bottom right viewport window, we realize that there are some dimensions that can show in this viewport window, such as the radius and diameter dimensions for the small circle. Let's add the 3" equals 1 foot annotation scale to these two dimensions. Double left click again inside the top right viewport window to open it. Left click one time on the radius and diameter dimensions. Right click on your mouse and in the right click contextual menu, left click on Annotation Object Scale and left click again on Add Delete Scales. In the Annotation Object Scales dialog box, left click one time on the word Add, and when presented with the list of scales, scroll down and select the 3" equals 1 foot annotation dimension scale. Click OK to exit the list, and click OK to again exit the dialog box. These two dimensions now display in the lower right viewport window. Note that the small rectangle has not had any dimensions applied to it to this point. Left-click one time inside the lower right viewport window to switch active viewports. Verify that the dimension layer is the current drawing layer, either in the Layers panel at the top of the display or in the Properties panel. In the Annotation panel, pull down the Dimension Styles menu and select on Linear Dimension. At the command prompt to select the first extension line, select the upper left-hand corner of the small rectangle, and for the second extension line, choose the upper right corner of the small rectangle, and move your cursor up a short distance and left-click to place the dimension line. Note that this dimension only displays in this 3" equals 1 foot annotation scaled viewport. Press the Enter key to re-enter the linear dimension command and place another dimension string at the right end of the small rectangle. Double left click outside the viewport to close the viewport window. Save your drawing. Double left click inside the lower left viewport window to open the window. Unlock the viewport window. Pan the small circle and small rectangle in the view so that they are generally centered in the viewport window, and then lock the viewport without exiting the viewport window back to paper space. Glance down at the annotation scale displayed in the Drawing Aids toolbar to verify that the scale was not errantly changed from 6" equals 1 foot scale. If this scale factor does not display, the user will need to unlock the viewport, reset the scale factor, and then relock the viewport. Left-click one time in the lower right viewport to switch the active viewport window. Select the two linear dimensions and the diameter and radius dimension, and let's follow the same preceding steps to add the 6" equals 1 foot scales to these objects. Right-click your mouse, left-click over the object scale, flyout, left-click on Add Delete Scales. In the Annotation Object Scale dialog box, select the word Add. In the presented list of scales, scroll down, left-click on 6 inches equals 1 foot, click OK to exit the scale list, and click OK again to exit the Annotation Object Scale dialog box. These dimensions now display in the lower left viewport window. Save your drawing. Note that our original text object, located at the 0, 0 coordinate point, is obscured by our geometry. And recall that this particular mText object has numerous scales assigned to it. One would assume that if you move this text object in one of these viewport windows to a different location within the viewport, that this object will be relocated in each of the other viewport windows. This is not the case. Left-click in the upper left viewport to switch the active viewport window. Left-click one time on the mText object and note that the text object is highlighted in each of the viewport windows. And the grip appears at the upper left-hand corner of the text. Recall that this text was justified in the top left corner when it was created. Hover your cursor over this grip and note that the grip changes color to red. A visual cue dialog pops up stating this grip is the mText location point. Left-click one time on this grip and stretch this text down below the large rectangle. Note that this instance of this text object has moved while the text object in the other viewports has not been affected. Let's relocate the text in the other viewports. Left-click one time inside the upper right viewport to switch active viewports, and repeat the last step to move this text object in this viewport window. Select the text object, left-click one time on the grip to stretch the text object just above the small rectangle. In the lower right viewport, stretch this text object just to the left of the small circle. And in the lower left viewport, stretch the text object to a point in between the rectangle and the circumference of the circle. Double left click outside the viewport window to close the window and save your drawing. Navigate back to Model Space by selecting the Model tab at the lower left corner of the display. Note that our text object now displays at the location it was relocated to when modified through the 1 inch equals 1 foot viewport. And when we select on this text object, ghosted images of the other 3 locations for each of the viewport scale factors display on the screen. Save your drawing. We will make some final adjustments to our drawing file in the next video and begin drawing in earnest.